Greetings, my students. Saxon Algebra 2, Lesson 8. We're going to start with a quick review of what is a polynomial. That is such a scary sounding word, and it's a shame, as John often points out, because polynomials are not complicated. They can be quite simple. These are all examples of polynomials. These are what we call single-term polynomials or monomials because they only have one term. We can have what's called a binomial, which has two terms. That would be like x plus 7. Or we can have a trinomial, and we love these. That looks like that. It has 3 parts, okay? So these are specialized names. They all fall under the category of polynomials. There are a few characteristics of polynomials that are special, like the coefficients have to be real numbers, and the variables only have whole number exponents. There's a few simplifying things, but they don't get too messy. And so this word should lose its power. It's not scary, it's not hard. So I just want to throw that out there and tell you that we can measure the degrees too. This is a second degree polynomial because its highest exponent is a 2. This is a first degree polynomial because its biggest exponent is a 1. There's something special when we try to graph. I'm just going to write this up. When we graph first degree polynomials with 2 unknowns, so that means they have an x and a y, but nothing squared. They're just plain x and plain y. They create a straight line. And the formula that we often use to describe this relationship, ready? Wait for it. This is called the slope-intercept format of a line, and this is exactly what we've got. We've got 2 unknowns. The m and the b we fill in the blank later. This is kind of the generic form, but the x and the y are going to be unknowns. They're first degree because neither of them are squared, and that is why we know that whenever we graph them, they make a straight line. Don't worry about this. This is just nice to know. But of course, this we're going to talk about endlessly starting now. Let's graph some linear equations. Now, John wants to drag us back into this crazy thing of we're given an equation, we're told to graph it. His strategy in the beginning is to make a table and choose some values for x and y and put them through and calculate them. No, we're not going to do it that way. That just is needlessly confusing and annoying. We're going to skip straight to the slope-intercept style of graphing. So if you look in the book, you'll see John doing it another way. We're not going to do it. The first step, we want to arrange our equation in y equals mx plus b format. This is not the way we want the equation to look. That's the way John gave it to us in the book. We want it to be y equals mx plus b format because that makes it super easy to graph. Once we get it in this format, we've got all the information we need. So we need to rearrange this. So I have 2x plus 3y equals 6. And I want y equals mx plus b. So I'm going to send the 2x over here. 3y equals, and I'm going to put the x first because that's how we like it. We like the x term and then the plain number. And then I have to get rid of this coefficient. So to simplify it, I've got y equals minus 2/3 x plus 2. This is the standard way we write this. We put the fraction kind of by itself and then the x after. That will become useful in a minute, you'll remember. And then we can reduce that if possible. Having a fraction here is no big deal. Having a fraction here is a little more tedious, but this is fine. We don't worry about that at all. Now we've got everything in a graphable arrangement. So we don't have to do anything more. So we draw ourselves a graph. If you have graph paper / if you like things to be super neat and precise, use graph paper. If not, be very neat, as I draw a really crooked line, as neat as you can because it makes a difference in how your answer looks. What I always do is I use the blue lines of the paper on my y-axis, and then I just try to approximate them on my x-axis. Remember, those are the two axes. Remember, it's a number line. I'm not going to put in all the numbers. 0, 0 is at the beginning. 1, 2, 3, 4, 5. Remember, in the pair of numbers, x always comes first and then y. But we don't really need that right now. This number and the sign is called our y-intercept. And it's where we start intercept. We graph that first. And what we do is we simply go to this value on the y-axis. I'll give you a second to catch up. I know I'm writing a lot. Okay, so positive 2, this is the y-axis, the up and down. The y-intercept is the place where our line crosses the y-axis. That's positive 2. All right, so that's the first part of graphing. Now we're going to use this information. I'm just writing for a minute. I'll just wait for a second and let you catch up on all that before I talk more about it. We've graphed the y-intercept. We take the next step starting from the y-intercept. If our slope is positive, we're going to go up the number of steps in the numerator, and then we're going to go to the right the number of steps in the denominator. If the slope is negative, as in our case, the first number actually tells us to go down. The bottom number always tells us to go to the right. Okay, so we have a negative slope. So that tells us we need to go down 2 and then to the right 3. And we make a second point there. Okay, so this is our second point. And then the third part of this is to connect the points. And you can use a straight edge. I'm just trying to eyeball it. We draw a line that connects the 2 points. And that is the graph of this line. So what that means is that for any point x that you would like to choose, any number in the whole world, multiply it through that or put it through that equation, and the y value associated with it will lie on this line. All the points will make that equation come true. This is right, by the way. Yay us. All right, now that we did one, John's gonna get on board with us and say, okay, let's do it the slope-intercept way. Example 8.2. Use the intercept slope. I call it slope-intercept. John calls it intercept-slope. Use the intercept-slope method to graph the equation 2x. Oh, excuse me, I'm yawning, but that doesn't mean I'm bored. I love this stuff. Okay, we're gonna graph this one. We're gonna follow the same process. Step one is rearrange. We subtract the 2x. Wait, this is the very same problem. Yeah, this is the very same problem. We're not gonna do it again. Let's move on to 8.3 and use a different one. Y equals minus 3x minus 3. John had done the first example using that little table of points, and then he'd used the same equation in the second example to do it the slope-intercept way. We did it slope-intercept to begin with, and so we don't need to do it a second time. We've already seen it. Now this equation is nice because John's already got this in the right format. I recommend you write this at the top of each homework page so you can remember, oh yeah, that's what this is. So we're ready to graph. All right. I also think it's perfectly fine. Just put in a couple points and add more if you need them. I also don't demand that you put arrowheads on your lines. I'll do it this time. From now on, I probably won't. I don't demand that you label your axes. I'll do it today. Those things are all basic, and I assume at this point you know. All right, first thing we do is we graph our y-intercept. It's -3, 1, 2, 3. Okay? And our slope, it's not a fraction. So how do we make it a fraction? Oh, we make it -3 over 1, okay? Slope always needs to be a fraction. This is negative, so it's gonna be the sink, which means we go down over the run, which is always to the right, okay? The numerator can switch whether it's negative or positive, but the bottom is always to the right. Okay, we need to go down 3 more, so I'm gonna have to extend this, aren't I? There's -3, 4, 5, 6. That's -6. So I'll go down 3, 1, 2, 3, and then to the right 1. And there is our line. What matters to me is not that you draw a perfectly straight line, although it's nice. What matters to me is you get these 2 points right. So if I was on a test, if we were looking at a test or a review problem, I'm looking to make sure that your points are at -3 on the y-axis and then down 3 and over 1. That's what I'm looking to see. This is the right answer. Yay. That's the end of lesson 8. You guys, graphing linear equations is one of the key concepts that algebra covers. And so if you end up taking an SAT, I don't even know if that's going to happen in your lives, but this is one of the main topics that any kind of algebra assessment is going to cover because, so if you don't take the SAT, you'll take some sort of placement test when you get to college. Just like when you go to Edmonds Community College, you take the AccuPlacer. It's a placement test rather than an admissions test. But they're going to cover this. This is a huge, big deal in algebra. So make sure you understand it. Ask me questions. On we go. Let's see. Just a reminder for our check-ins. You have 2 options this week. You can check in with me on Thursday between noon and 2 You can check in with me on Friday between noon and 2. Okay, you have your option only once. You don't have to check in twice, just once. Literally all we will do is I'll say hi to you. I'll ask you how it's going. We'll chat briefly. Then I'll give you a review problem. You'll work it. I'll show you the answer. The end. Okay, so it's not a big long thing. Check in with me one or the other. If you didn't check in with me last week, make sure you check in with me this week, but you don't have to do like a makeup or anything. We'll just cover both bases at once. I will have you work 2 review problems though, so it'll take a little bit longer than usual. You also do not have to call me ahead of time to say, hey, can you talk now? Just call me. You can use any video chat platform that you want, FaceTime, Facebook Messenger. I can do WhatsApp. Let me know what you want to do if it's not one of these. But I'm here. I'm just sitting by the phone waiting for someone to call. If multiple students call in a row, I'll call you back as soon as I'm free. All right? Yay, we're done. Lesson 8 is history. Thank you. Goodbye.